Hello and welcome to some more physics. Thanks to Kerry, we spotted that the last video wasn't linked on the tasks in the Edmodo thingy. It is now, so you have two videos to look at. How exciting is that? Today we just have a quick look here at the exam paper we asked you to look at. We'd already, or at least the last video, looked at question 1, 2, 3 and 4 from the 2019 exam craft. It's as good as any paper to look at. So we asked you to look at question 5, which is a whole set of short questions. There they are, typical short questions, nothing major in them. We'll just have a quick look at them and their answers there now. Right, first one, shortest stopping distance, car traveling 20 meters. This is just simply using one of the formulas, V equals U plus AT. So they've rearranged it here and they found the answer. Check it out, right? I'll put these answers up on a link so you can print them out, look at them, go over them again. Distinguishing mass and weight, well, mass, force of gravity, weight is the force of gravity acting on an object. Mass is the amount of matter in something, or a measure of its inertia is another way you'll find it defined. So weight, being a force, is measured in newtons, and the weight changes from place to place because your weight on the moon will be different than Earth because, again, a question asked previously, why? Because, of course, the force of gravity on the moon is less. The mass, the amount of stuff, of course, doesn't change. And mass, by the way, is measured in kilograms. Okay. Why does the temperature of an athlete reduce? Well, that is latent heat of vaporization. As the liquid evaporates from the skin, it takes in latent heat from the surroundings, which is the athlete, and brings us nicely back to the old fridge. Now is a good time to look back over the fridge, look over questions on the operation of the heat pump. So a heat pump was defined as something that transferred heat from a hot area to a cooler area. So your fridge does that. So here is your fridge, and inside the fridge you have a set of pipes, and outside the back of the fridge you also have a set of pipes. And if you're completely bored at home, just go and have a look at your fridge. Take it apart. Well, maybe don't take it apart. What happens in your fridge? Well, a liquid is allowed to come in here. So through an expansion valve, I'll just call it EV for now. An expansion valve allows the liquid to come in, expand into a larger pipe where it evaporates. The evaporation takes in latent heat, so you can say liquid evaporates, takes in latent heat, and cools fridge. That gas that's formed then continues on, and down at the bottom there's a pump or compressor, and it forces the liquid is compressed, well, I should say the gas that's come out into a liquid, releases latent heat of vaporization. So at the back then, heat released. Whereas here, heat goes in. So that's a heat pump. Heat is removed from one side to the other. So heat normally travels from hot to cold. Here we're moving it from a cold area to a hotter area. So heat pump transfers heat from a cooler area to a hotter area. That's the definition of our heat pump. Again, used in air conditioners, things like that. Anyway, enough of that. Moving on to some more of the questions. Focal length of lens, which is the power, so that's just using the 1 over F equals 1 over P formula. Power, by the way, is given in meters, so 1 over P, so it'll be focal length will be 1 over, in this case, 3, so that's 0.3, which is 0.3 of a meter, or 33 in this case centimeters if you want. How is energy transferred? Electromagnetic radiation from the sun. Capacitors, we'll look at those another day, but basically a couple of formulas for capacitors, and one of them is the energy stored, half CV squared. That's all they're looking for there. Why is a magnet point north? It's attracted by the Earth's magnetic field, right? The principle on which the definition of the ampere is based. Two current carrying conductors will exert a force on each other. So that's just the principle. The long definition, if you were lucky enough to be asked that one, the force acting on two current carrying conductors of negligible cross-sectional area, 1 meter apart in a vacuum, is such that the force is whatever it is. Go and learn that one off. 2 by 10, I don't know, there's a big longest definition in the book. Find that one, repeat it to your family all day. See how they like that. How are electrons accelerated in a cathode ray tube? Well, they're accelerated there. It says by the electric field, the potential difference between the anode and cathode. You can say either. So the electric field between the anode and cathode. How are they emitted, by the way? Thermionic emission. What characteristic of light controls the current in a photocell? The current is controlled by the brightness, the intensity, right? The more light that shines on it, the more electrons are emitted. However, whether the electrons are emitted or not depends on the frequency. If it's below the threshold frequency, no electrons are emitted, no matter how bright the light is. That's the whole key of the photoelectric effect. And that's that one there. And as always in the mock, they sort of mix that up. The photocell is in your course, but then they throw in this thing about a kaon or something like that. It consists of a strange quark, and I think what type of hadron is a kaon? It's a meson, because kaons contain two particles in it, an up quark or a down quark. So two of them in it makes it a meson. Mesons are middle between the hadrons and the other ones there at the lower end, whatever they were. Have a look up again at those. So we'll talk about particle physics another day. Let's see. Question 6, typical question. Velocity, angular velocity, asks you to derive here the formula, the relationship between velocity and its angular velocity. Then usual, fairly simple one for higher level paper. Kinetic to potential energy, potential to kinetic energy is the energy changes when a student threw a ball up in the air. It doesn't ask why the student threw the ball up in the air, but there you go. Then the rest of it, time taken for the ball to reach its maximum height. Typical question, same as the ones in the book. Just try it out first, hopefully you have, and see if you get the same answers here. The maximum height reached, again, maximum height, of course we know at the maximum height the ball will have zero velocity and maximum potential energy and things like that. Right, so finally, yep, that seems to be all that's in that question there. As I said, we'll put up that as well. Yeah, as I said previously as well, keep going over the experiments, right? Draw out the diagrams. Keep going over the questions on the experiments. Write them out, try them, see did they match the marking schemes either in the likes of this or in the study clicks. So the more of that you do, you want to keep busy. Whether or not to go ahead with Leaving Cert, you want to be prepared just in case, whether it's a shortened one, a full length one, whatever. But if you sit back and forget about this stuff, it's amazing how quickly it disappears. Yeah, physics, yeah, what is that again? Anyway, till the next time, bye for now.